planter, variable rate planter, into my GPS system? Kind of confusing to me. Okay, well let's explore. So providing immediate control, it combined with a GPS. Oh, now I'm combining it with a GPS system. I'm not plugging it into a GPS system. It varies the population rate on the go. Okay, so I've got a GPS system and I have this unit. So, how does that work? Okay. Fully GPS compatible. Okay. Does that mean I can plug my GPS right into this? Because what comes out of a GPS? Yeah, it's a serial port, but what's the kind of information that comes out? GGA, NEMA strings. So I plug this GPS unit into here, my NEMA strings go into here, and I adjust my rate based on NEMA strings? All I'm getting is latitude and longitude and speed and things like that. How do I adjust my rate based on that? GPS is ready for operation, accurate. Adjust the rate, doesn't interfere with the ability to run fertilizer. So, wow, that's pretty good. It sounds great, right? I just buy this and a GPS unit. And what's missing, though? With GPS capabilities, adjuster rate changes population rates on the go.
Actuator.
That's interesting. So it changes it on the go. Plug your Orthman controller into your existing GPS system and it's ready now for operation. What this is actually a controller that instead of increasing the rate using valves down here, has a little serial port, like you said, in the back. And on that serial port, the input is like a rate change. So I can input my change of the rate. I can say, okay, instead of putting on so many seeds per acre, I'm putting on more seeds per acre, just like we decided with the liquid application. And then if the more seeds per acre measures the speed and then controls that drive. But you can't connect a GPS right to this. This is not GPS. You have to have a map. And that map then defines what rate I want at different parts of the field. So the GPS actually goes into that map, just like we talked about before, determines the population rate at the location, and then sends that rate change command to this. And then this controls the hydraulic motor to put on the proper rate. That's how the system works. There's no map embedded into here. I can't connect the GPS directly to this. But it sure indicates to me like I can. So I guess the point I'm trying to make here is that I'm going to show you some equipment, and we're going to talk about that equipment. But we're going to say, is this really GPS compatible? Can I do an adjuster rate GPS system? And the only thing new about this is that I can input a rate change command into the back of the serial port as opposed to doing it with my knobs on the front. So there's a little bit of false, in my opinion, false advertising that goes on utilizing these systems. So that's another aspect of the class we're going to look at. What do these things do? How do they work? And what are their features and what kind of inputs and outputs do they require? Okay. The last thing that one of the last things we're going to do in the class is talk about remote sensing. And after we cover the project and equipment, we're going to move into the last chapter of the class, which I'll talk about next week. And that's going to be our last remote sensing lab. And so we're going to go out and capture some remote sensing data. How many people have used Image Analyst in this class, which is ERDOS type of product, but now it's an extension within ArcGIS. Okay, I don't know if I'm going to introduce that or not in the class, but it's a way of taking satellite maps and analyzing it for NDVI and other features. We talk a lot about NDVI, but we may do some hands-on remote sensing of chlorophyll color, looking for laser rates, things like that, based on some handheld units as opposed to satellite imagery. Okay, so that's where we're going in the class. We'll talk a lot more about equipment, and this assignment right here won't be due for a while until at least after the test, because this will be on test 4 type of material.